Hello, this is a video tutorial about how to use Weka to classify the data mining capstone task 6. So the first thing we need to do, obviously, we need to download the dataset. So once you download that and extract the files, you'll get the 3 raw files here. But in this tutorial, we only use this one and this one here. So I wrote a simple Python script to process the raw data. Basically, what it does is that it combines the raw reviewing text with a label that provided by the sample, by the course, and construct actually 2 files, which is the ARFF file for test file and ARFF for the training file. The ARFF is the file format for the Weka. So by running this, and it will generate 2 files here. One is for training, one is for test. Let me show you what it looks like. So for the training, let me just show you it here. So it starts with the name of the file. It's actually not right, but it's fine. It's just a label. So and it's a CSV format. So the first attribute is a string, and second one is the class. If it is past the health check or not. So take this one as an example. The first instance here, the very long text all here is the first attribute, which is the review text, and the second attribute is a class file. So it's the same as the test file here. So the test file has the same structure, but excuse me. The only difference is that after the long text file, we put question mark here instead of the 0 or 1, because we don't know what label we need to put in here. That's actually the question we need to answer for the task 6. We need to use the knowledge we gained from the training file to predict the value here. So now we have 2 files, the training and the test. We start the Weka. We click on the Explorer, and it will bring up this Explorer. And in the open file, you first load the training file, and then you go to the Classify tab. Under the classifier, you need to choose the classifiers, meta, and the filter classifier. Click on that. Excuse me, I had a bad cough today. It will bring up a detailed configuration window for you to select. The first one, for the text mining work, we need to use the naive Bayes multinomial algorithm. There is not much things to configure, so let it as it is. And for the filter, we need to choose a string to word vector, which is here. So it's under the filters unsupervised attribute, and it's down below in the string word to word vector here. Click on that. Inside here, the configuration, there are a lot of things that you can play with. So that's the main task of this assignment, that you need to think about and choose the best configuration parameters here to get the best result. So once you configured here, when you need to do some testing, that you can use the percentage split. What is 66%? What it means that you will take the training file as a whole, but use the 66% as training file, and the rest of the 34% as testing to predict if it is good or not. So if I run that, you can see that by the current configuration, the classification correct is about 69%. So if you're not happy with that, you can always go back to the configuration parameters I just showed you, and you can play with that to see that if you can get better result. But the next thing I want to show you is that you need to first select the supplied test set, and you need to choose the test file that we just generated. Okay, and you also need to output the predictions to a file. So in here I choose CSV file, and I output the file to a local file here. So hygiene prediction, this file. So okay, everything looks good, and I just run this classification job, and you can see that it's start to analyze and predict all the instances we listed in the testing file. So just wait for 1 minute or so, and it'll finish. Don't worry about these not a number value here, because we don't care about that. That's the instance numbers we have been analyzed, and after that it will generate a file here, this one. Let me show you. Yeah, this file is just been changed. So here, that's the output of this file. So you can see it's a CSV file. This is the instance number, the actual label. We put a question mark here. Don't worry about the one column thing, not necessary, not very useful for us. And the prediction, this number that we need to have. So by format, we need to format and extract these values from the output. So I have a simple Python script that extracts this value by running this command, this Python script. It will generate this file, this format file, and once you have that, you can submit the file to the task 6. Okay, that's pretty much how I worked the task 6. Hope you enjoy that. Thank you very much.